Okay, in this activity you're asked to identify the dependent variable, the independent variable, and the constant. So first we're going to read through the information. It says Michael decides that he wants to discover the heaviest liquid in his family's refrigerator. I'm going to underline that because that is what we're looking for. That's the reason we're doing the experiment in the first place. After finding a scale to use and a container to hold 8 ounces of each of his liquids, he begins gathering data. This is the data table that he has created. I'm going to also underline 8 ounces of each of his liquids because that's another important set of information that you need to know. So looking at the data table, we have milk, which is 46 grams, syrup, which weighed 63 grams, water, 42 grams, and soda, 45 grams. So now we're going to use this information to answer the following questions. Number 1, what is the dependent variable in Michael's experiment? Remember that dependent variable is the one that we measure. Independent variable is the one that we change or manipulate. You'll see that word also. So what is the dependent variable in Michael's experiment? What are we trying to measure? So we can figure this out by going back and reading why we're doing the experiment in the first place. So that's that first sentence. Michael decides that he wants to discover the heaviest liquid in the family's refrigerator. So looking at our answer choices, which of those goes along with one of the things in the sentence that we can actually measure? The different liquids Michael is testing. B, the final weight of the liquids Michael is testing. C, the amount of liquid Michael measures. Or D, the container Michael uses for measuring. So what we're actually going to measure in the end is B, the final weight of the liquids Michael is testing. Now, the final weight of the liquids that Michael is testing depends on what kind of liquid it is. So, number 2, it says what is the independent variable in Michael's experiment? Independent variable is the one that we change or we manipulate. So, and we can only change or manipulate one thing in an experiment for it to be a valid experiment. So, what did we change? We changed the types of liquids that we use. So, A would be the answer choice for number 2. Now, you can check this also and make sure that you have the right answer by asking the final weight of the liquids, which is your dependent variable, depends on the type of liquid being used, which is the different liquids Michael's testing. So we wouldn't want, B would not be an answer choice for independent variable. The amount of liquid Michael measures, we already know that all of the liquids are in 8 ounces because we have to keep that the same. We can't change more than one variable. And then the container Michael uses for measuring, it doesn't really matter as long as you have 8 ounces in the end of each liquid. So number 3, what is the constant in Michael's experiment? Remember, constant is a thing that stays the same. Okay, we don't want to change more than one variable. So what has to stay the same in order for this experiment to be a valid experiment? The different liquids, we know that's not an answer choice because we know that that is our independent variable. Also, the final weight cannot be an answer choice because that's our dependent variable. That's the thing that we're actually testing for. We're actually measuring in the end. C, the amount of liquid Michael measures, or D, the container Michael uses for measuring. So what stays the same? That's going to be answer choice C, the amount of liquid Michael measures. We want to make sure that we do 8 ounces of milk, 8 ounces of syrup, 8 ounces of water, and also 8 ounces of soda. Because if we did 8 ounces of milk and say 2 ounces of syrup, our weight in the end is not going to be accurate because we changed the ounces for each one. So we want to keep the ounces the same, and that was told to us in the top up here where it says 8 ounces of each of his liquids. So that is 1 through 3. So we're going to go to the next one. Okay, this is the same thing. It's just now obviously a different experiment, but you're doing the same thing. You're finding the dependent, the independent, and also the constant. So Jane decides that she wants to discover the impact that height has on the size of the crater made in a bowl full of flour. So again, I am going to underline that sentence because that's the whole reason that we're doing the experiment. After finding her favorite golf ball and filling a red mixing bowl up to the brim with flour, she drops her golf ball from increasingly higher heights. This is the data table that she has created. Height of the arm above the bowl. She has 1 foot, then she dropped from 3 feet, then 4 feet, then 5 feet. The size of the crater, 2.5 inches at 1 foot, 5 inches at 3 feet, 7 inches at 4 feet, and then 9 inches at 5 feet. So, using this information, we're going to answer the following questions. Number 4. What is the dependent variable in Jane's experiment? Remember, that's the one that we can measure. So, what are we actually measuring in the end? Let's read that first sentence again. Jane decides that she wants to discover the impact that height has on the size of the crater made in a bowl full of flour. So, in the end, what do you want to measure? What do you want to be able to measure at the end of the experiment? Why are you doing the experiment? Your dependent variable is going to be B, the final size of the crater that the golf ball makes after Jane drops it. Now again, just like before, we can answer number 5, what is the independent variable, by asking what the dependent variable depends on. Okay, the size of the crater depends on what? And our independent variable for this experiment is going to be A, the height of Jane's arm above the bowl she is using. Okay, so the size of the crater is 2.5 inches. That depends on how high she drops the ball from. So 1 foot. And you can see that the size of the crater changes based on the change in the height of her arm. Now, what is the constant in Jane's experiment? We know that it's not A, and we know that it's not B, because those are our independent and dependent variables. So we have C and D left. The golf ball that Jane drops into her flour, or D, the amount of time that Jane's golf ball takes to fall into the flour. Remember, the constant is the thing that you want to keep the same throughout the experiment. You can't change anything else, because we can only change one thing, and that was the height at which she dropped the ball from. So we're going to want to keep the golf ball that Jane drops into her flour. That has to stay the same throughout her dropping it from 1 foot, 3 feet, 4 feet, and 5 feet. Because you don't want to use a golf ball at the beginning for 1 foot and then change to a baseball and then a basketball and then a soccer ball. You want to make sure that you keep the ball the same.